Now we discuss about the boat form of cyclohexane. So in boat form of cyclohexane, you can see the 4 carbon atom 2, 3, 5, 6 are in one plane, while the first and fourth carbon are above the plane. You can see this is somewhat looks like a boat. That's why they are called the boat form. And this is Soho's representation of the boat form of the molecule cyclohexane. Now, while this one is the Newman representation of the boat form of cyclohexane, and actually they given these two eyes and in order to view this molecule in Newman projection, which I explained earlier in the case of the chair form, and you need not be bothered that much in these cases. Anyhow, now we will discuss about the relative stability of the chair and boat form of cyclohexane. Before that, we go through a video.
In chair form, there are 6 carbon-hydrogen bonds which are parallel to the axis of symmetry, and they are called axial bonds, denoted by A. The remaining 6 carbon-hydrogen bonds are directed at an angle of 109.5 degrees to the axis of symmetry, and they are called equatorial bonds, denoted by E. Thus, each carbon atom in chair form will be attached to one axial and one equatorial bond. And if we consider the adjacent CH bond, they are all staggered with respect to each other. Thus, the chair form is free from torsional strain and bond opposition strain. In the boat conformation, there are 4 boat axial and 4 boat equatorial bonds. Then there are 2 black pole bonds and 2 bowsprit bonds at the carbon atom 1 and 4. But if we see along the carbon-carbon bond, then all the CH bonds are equalized with respect to each other. Hence, this configuration has maximum torsional and steric strain. Further, the hydrogen atom at 4 carbon atoms, that is flag pole bonds, are closer than their van der Waals radii. Therefore, there will be strong van der Waals repulsion. Thus, transannular strain is also high. In addition to...
So, what this explains is there are 2 types of bonds. You can see there are axial as well as the equatorial bonds. So, there are 6 axial bonds as they explained in the video, and these axial bonds are actually somewhat parallel to the plane. Not parallel, sorry, the perpendicular to the plane, while the equatorial bonds are somewhat parallel to this plane. And this is a complete cyclohexane having both equatorial as well as the axial bonds. Now these are the different view of the molecule cyclohexane, and this is ball and stick model. So in each carbon you can see there are 2 axial and equatorial, and this is another view of molecule cyclohexane from seen from the side, while this is the other one. Anyhow, we'll go back to the discussion of the stability of the cyclohexane, the chair form as well as boat form. We'll go back to this figure. You can see the cyclohexane, the chair form in Newman projection. You can see here this is a staggered conformation, staggered one. So that means all the hydrogen, the back hydrogen is in between these 2, while this hydrogen is in between these 2. All are the staggered conformers. While you look onto this one, the boat form of the cyclohexane, this is eclipsed one. So this is one reason why the chair form is more stable, because the chair form is the staggered conformer while the boat form is the eclipsed one. Other than that, there is another reason why the chair form is more stable. Look onto the first and fourth carbon. In first and fourth carbon, what happens is these 2 hydrogen come more closer And these two hydrogen on the first and fourth carbon, which comes more closer, are usually called flag pole hydrogen. Flag, F-L-A-G-P-O-L-E, flag pole hydrogen. And there will be these flag pole hydrogen repulsion, and thereby torsional strain will be more. So these are the reason why the chair form is more stable compared to the boat form. You can see in this chair form there is no flagpole hydrogens. There is no flagpole hydrogen, while here you have the flagpole hydrogen which are coming more closer to each other. That's why this chair form is relatively more stable compared to the boat form. Anyhow, that's all about the conformers of cyclohexane. Now on the next day we'll discuss about the conformations of methyl cyclohexane. Okay, thank you.